welcome Kent. Just,
Great, thanks. Last talk of the day. Hope I don't bore you. I'm bringing you the perspective of a civil engineer. This room is full of mechanical and chemical engineers, and I know what you guys are thinking. I had a friend tell me that you know, those ponds that you civil engineers build, they're just engineered holes in the ground. Well, I hope the perspective that you get from this little presentation gives you a feeling that an ash pond is more than just a little hole in the ground, and that it has the potential for perhaps some big liabilities and some big expense. Drawbacks of learning by trial and error. If there's any image that I want you to leave with after this discussion is, don't learn by trial and error. Plan. And even with a dumb old ash pond, there is significant risk in not planning. So keep this image in your mind as I discuss some of the things that I've learned in my 32 years of experience in working with residuals in the mining industry, in forest products. There are many other industries that hydraulically deposit residuals, so the power industry is not alone in some of the challenges it's facing now. What are some of the drivers? Obviously, everyone thinks of the regulatory drivers, but that's not the only driver in an entity considering closing an impoundment. There may be plant retirements. You want to cover things up, button it up, make it a saleable property. You may make changes to your facility operations. Perhaps you need access to some property that's occupied by this footprint. It may be in some very desirable location that you want to reclaim, so there may be an opportunity to claim that simply by closing that ash pond. There may be some environmental liability management things. There may be some environmental impacts that you want to clean up and minimize. And of course, there is the omnipresent political and social eyes that are upon these facilities. By nature, these are on the rivers and waterways. And after some recent events at Dan River and Kingsport and in West Virginia, it's under high scrutiny. So there's no getting away from that. It may be one of the drivers in wanting to close some of these impoundments. It's unfortunate that the gentleman who is going to precede me was not here. I was hoping he was going to get into some of the details of some of the regulatory requirements. The bottom line is we anticipate that the rules are going to go Subtitle D-ish. And we don't know all the details. Subtitle D, as you probably know, and I don't mean to insult anybody's intelligence, but it's basically the same laws that govern our solid waste in industry and in municipalities. So we're thinking it will be somewhat like that, which means that this material will have to go likely in the future in some kind of lined facility where there's monitoring, where there's leachate collection, where the potential impact due to leaching of materials from these piles into the groundwater is going to be minimized. Well, these rules are not yet finalized. They're due to be finalized on December 19th. I understand that it is now into the Office of Information and Regulatory Review right now in the White House. And typically that takes 60 to 90 to 120 days to review. It may meet that regulatory deadline. It may not. We don't know. But that's something that we all sit and hope to find out soon. In a nutshell, these ponds follow under the lists that you see there, the rules that we anticipate it's going to include, which means that the rule will become effective 6 months after it's promulgated. Ponds not meeting liner requirements will have to stop accepting waste within 5 years. Groundwater will be monitoring will be expected within a year of the effective date. Ponds will have to be closed within 2 years of the last receipt of any waste. And I mentioned the deadline. It's likely to be implemented on a state level, we think. In other words, states will be given the authority, much like Subtitle D, to govern regulation of these impoundments. And as we might expect, it's very likely that there is going to be some litigation associated with this, but we all wait to see what happens. Interestingly, North Carolina just presented their first in the nation coal ash laws. It's expected to be a model for other states. It applies to wet and dry ash ponds, including ponds that are covered and are no longer in use. I think that's significant. Effective October 1st of this year, no new ash ponds were to be allowed. And one of the features of this new rule is that ponds would be designated as high risk, medium risk, or low risk. And the closure schedule would be based upon the risk that each one of these ponds was assigned. There'd be no wet disposal at all by 2020, and the new law requires ash to be disposed of as a solid waste, as you might expect if it's looking like a Subtitle D type of facility. The risk assignment and the closure plans are all going to be reviewed by a coal ash commission. And those risks I might mention are most likely going to be affected by their location, by the type of facility they are, if they're wet ash, cold, dry ash, etc. So not every pond is going to be rated the same. If it's a higher intermediate risk ash pond, you've got two options. You can remove the ash, temporarily store it somewhere on site as you construct a line cell to put this in, and then when you're finished, cover it with cap. The other option is to do what we would call a clean closure, dig it all out, and make it into a daycare playground or something. Now, a low risk ash pond has the option of being capped by the solid waste standards. And in most states, in my experience, if there's an unlined pond, they typically make you cover it with a soil cover equal or better than the soil liner at the bottom. So they assume that you have a minimum 1 × 10⁻⁵ centimeter per second soil liner on the bottom. You typically have to put an equivalent liner on the top. That's what's typical. What's interesting is that there is some allowance for use of CCR as a structural fill. For instance, Duke Energy is using coal ash to expand the runways at Asheville, and that has been going on for quite some time. Going forward, though, if they use more than 80,000 tons total, they'll have to put in groundwater liner monitoring liners and treat it just like a solid waste. So the advantage of using ash in that application starts to go away. Probably the advantage of doing it, though, is that you're not mingling your waste material with somebody else's. Cost recovery under this law is public utilities cannot recover costs from a spill, and there can be no new applications for discharges made until January 15th, 2015. The law is silent on whether a public utility can recover the costs of a pond closure through rates. So strategy, everybody's asking, do I close now, do I close later? There are some things that we want to consider as we make this plan in closing the ash pond. What are the costs? What's the future use of that property going to be? All important things. We want to be able to generate, here in front of you is kind of a generic decision matrix, where we look at pros and cons and we weight each of these things. They're all important, some of them more important than others, but we want to make sure that the plan that we develop is the appropriate one for this site. Every site is different, every ash pond is different, and it's important that we consider all of the important considerations. So the strategy, do we close now or later? It can be dictated by the regulatory framework and its timing. We're waiting to see what that shows. What's our short-term and long-term risk? If we leave this ash pond open, what's our risk there? If it's a retiring plant, we may want to close sooner rather than later. As I mentioned earlier, maybe we want to keep things buttoned up, make it not be a liability to a potential purchaser of a property or something of that nature. It could be related to availability of funds of and the costs. How are we going to pay for this? It may be related to changes in the way we handle the ash, whether it's wet ash or dry ash. So we have regulatory deadlines that affect this closure. We're considering the future site use, the pond size, the preparation of the design and bid package. That takes time. We have to plug that into our thinking and planning. We have to make allowances for regulatory approvals. So none of this spins on a dime. And so the other thing that I would want you to remember from this is it's better to plan now than later. And you're not spending but a fraction of the closure cost in the planning stage right now, but boy, can it make some difference down the road. We want to talk about the future end use of the property. Some things may be specific to that site. We may want to look at wetlands. Is this an area that, as we close this, are we impacted by the proximity to adjacent wetlands? On many ponds that are immediately adjacent to the river, that can be a consideration. What are the ash geotechnical properties? What is the location with respect to neighborhoods and existing developments? We're doing in my company an environmental cleanup that's in Connecticut that's very close to a very famous TV personality, and you can bet that that gets a lot of public scrutiny. And so the approach in closing an impoundment in that area is going to be different than one that's in the middle of nowhere in Mississippi. So we have to think about those things. Do we close in place or do we remove the residuals? Close in place means we cover them where they are. Removing them, we dig them up and haul them away. So we look at items such as what kind of market do we have for materials if we want to remove them and sell them? What are our long-term obligations? If we send them off-site and put them in a Subtitle D landfill mixed with municipal waste, what's our potential liability? Obviously, the deeper pockets are going to get the biggest attention. Should there be some kind of environmental liability at that landfill down the road? What's the future land use going to be? Sometimes that property has some very valuable use for an operating facility. Something that is often forgotten is there's sufficient borrow material on site. In closing some of these, as I mentioned, it's necessary to cover some of these ponds with a minimum thickness of soil. We assume that soil is everywhere, but that's not always the case. And this a project that I'm working on right now, one of the major considerations, and this is in New Jersey, any of you from New Jersey probably can appreciate this, there's not an abundance of borrow sources that you can find clean fill to cover something. That's an important consideration. And that's something that you have to plan on. Don't assume that you can go dig a hole in the ground and cover this over. You need to examine that. And it's got to be a clean fill. And one of the arguments that has often been made is, why should I create another hole in the ground to cover a hole in the ground? And so that's an argument that can be made with the agency. Many states have a lot of flexibility there. But I think you need to look at all the options that are available to you, even when it comes to availability of borrow material. So do we construct an on-site landfill? There is usually a very good economic argument to be made for that. What about staffing? If we build something on-site, who's going to monitor this and who's going to take care of the maintenance? An on-site landfill typically has 30 years of post-closure care required. That's under Subtitle D rules. Under similar rules for a pond, that might be a consideration that you build into your decision-making. What about the political and social pressures? Sometimes, no matter what you do, short of removing everything and hauling it into somebody else's backyard, is not going to please anybody. And then, of course, costs are always an underlying consideration as we look at these. So why do we need a plan? I've got a son who's a pilot in the Marine Corps, and he told me that when he was in flight school, they did an interesting thing that I'll tell you in a second how this relates to what we're discussing. He said that they put them in a hyperbaric chamber, and they partnered them with somebody who was going through this evaluation, and the purpose of this was for them to see how they behave and react in a low oxygen environment. So they put them in this hyperbaric chamber, and they do what they call the Pensacola patty cake. And it's very simple. All they do is this with their partner. That's all they have to do. No high-level thinking, no differential equations. That's all they're doing. And then they start to drop the pressure and the oxygen level in this chamber. And as you can see in the picture, they've got instructors who are closely monitoring, but they're filming this so that these student naval aviators can see how they react. And typically, they will do things that seem out of character. Sometimes a candidate will just go to sleep. Sometimes this person will just start giggling for no reason, or just sit there. And so they're filming this, and then they'll play it back to the student aviators and discuss what they felt and what they thought. And I asked my son what he was doing. He said, I just sat there doing this. And I said, what was going through your head as you're going through this? And he says, I knew something was wrong, but I didn't know what. And I think without a plan, when we get into a problem, we know something's wrong, but we don't know what. One of the things that I try to teach students when I teach at Clemson University in a construction planning course is that you've got to have a plan in order to have a contingency plan. With no base plan, there is no such thing as a contingency plan. So I emphasize over and over again that it's good and incumbent really to start planning now. We've got to evaluate the risks. Everything has a trade-off. There are always risks, risk and reward. And that seems to be something that is little understood by those who are insulated in government, perhaps. But we all understand that there's a cost to everything. There are several risks that we have to look at, and so we do an evaluation of the geotechnical properties. We look at the environmental conditions. Has there been a release already What about the social, political considerations in this? What does the existing pond design look like? How is it built? The Dan River spill, for instance, we know resulted because nobody fully appreciated the stormwater pipe that ran under this active pond, or actually it was a closed pond, but nobody really understood that there was a pipe that had the potential to corrode and collapse and to spill into the river. So understanding that is important in managing risk. We manage risk in understanding the permitting requirements as well as constructability. We've got to be able to build what we plan. And it's important that we understand that early in our planning. So we do groundwater investigations. We send drill rigs out there and we sample the groundwater and we construct a map of what we think the groundwater looks like, and we look at remedial options if there are impacts. We develop a closure plan based on such things as pond size. It's easier to close a small pond than a large pond. A large pond usually requires some staging of materials or staging of different phases. It's easier to close a small pond. What about dewatering methods? Where do we pump this water to? How are we going to treat it? Can we release it, pumping it directly from the pond? Sometimes we can, sometimes we can't. And then, as has been mentioned before, what's the final use going to look like? What about if there's, for instance, a groundwater impact? How do we integrate that into our closure? Can we kill two birds with one stone and clean up our groundwater problem by closing this pond too? That's something that we need to look at. Constructability, I mentioned health and safety. Health and safety can be a big concern, and we want to make sure that we address that in our planning. Site configuration constraints, I mentioned being constrained by a neighborhood, by a river, by wetlands. There are so many things, by overhead power lines. There are many things that can constrain us just by virtue of the location. And then, of course, long-term maintenance. I've always believed that we need to consider maintenance down the road, especially, as I mentioned, if we're having to maintain this for 30 years, we want to keep it as low maintenance as possible. Health and safety, you know, there's perception and then there's reality. This dust cloud you see there, that's the perception of those neighbors that are surrounding your ash pond as you're closing it. Reality is shown in the monitoring station, monitoring particulates, but we've got to establish up front what baseline levels are when we close these ponds. What are the particulate levels, and so that as these complaints come, as they usually do, that there is some scientific basis for addressing those. So we've got in-place closure. The pros are it's easier to close in place. It's less expensive. It keeps vehicles off the highways. It's close to our facility. We can monitor it. We can keep track of things. And we can even use this as a landfill base. If, for example, we're under the same type of rules as North Carolina proposes, we can turn that into a closure in place at the same time constructing the base for a new landfill. Of course, the cons are if we leave things in place, just like any industrial waste, we don't know exactly what's there. And to some people, that might represent a risk. And then, of course, there's always the social and political pressure to close. And it may not be feasible in a nice, pristine environment such as this. Sometimes the only option will be to remove that at least away from the edge of the river. And I think that's what Duke Energy is finding there on the Dan River, is they're having to close that particular pond regardless. They're having to dig it up, haul it away. So here are some of, in cross-section, here are some of the solutions. Upper diagram represents current conditions, and this is very typical of most ponds. You've got your residuals sitting in the pond, you've got water standing on top, and so it's dewatered either through perimeter ditching, through well points. You consolidate it and cover it with soil. And so one of the things that if we close it in place, we partially dewater it, we get the water out of there, and then we put soil on top. That soil has to come from somewhere, and it's much better to use a ash material as that fill material to give that crown so that top layer will drain rather than hauling material in from somewhere off-site or even on-site. And this is what a typical Subtitle D landfill looks like. You can see leachate collection piping. It's got polyethylene plastic liner. It's got gravel in it. It's an engineered system, more sophisticated than my Chem-E colleagues would give me credit for. So what do we do with this? This is actually a solar farm on a landfill here in Atlanta. It is not at all uncommon for a landfill to be turned into a use such as this to put a solar farm on it. And the nice thing about the utility industry is you've got the wires already there. Beneficial reuse. There's been some discussion about that. And there are several options that are available. It can be used in cement. Can be used as a structural fill. There are a lot of potential uses, but you've got to find the market, obviously. Haul distances become a major consideration in doing that. But if you've got the time, you can start developing the markets. And I keep coming back to the theme of plan early. You've got time. Do it now and think it through. So we've got disposal in an off-site Subtitle D landfill. We could build an on-site Subtitle D landfill. Typically part of constructing a Subtitle D landfill is meeting siting requirements. One advantage in working with most agencies in other industrial landfills is, look, you can say to them, I've already got a waste on site. Why does it make sense for me to take a pristine greenfield site and put a new landfill on top of that when I've already got an affected piece of property? It's much more cost effective to build on-site than haul off-site. For instance, you're typically paying $30, $35 tipping fee per ton, and for ash that's per cubic yard too. You can build an on-site landfill and get by, including maintenance, closure, post-closure, for about half of that. So there's usually a great incentive to build a Subtitle D type of landfill for storage of industrial materials on your own property if you've got the property. Okay. Closure by removal. You can remove residuals that's been used to stabilize roads. And this is what a typical landfill scenario looks like. Let me just move on. One of the things that is an important consideration is the removal of the water, either through, and the residuals through dredging, through mechanical excavation. An important point that I might make is that as you consolidate these materials and put them in one end of the pond, you can sometimes turn the other end of the pond into a wetlands area, constructed wetlands for treatment of leachates. And that can have a real advantage. Wetlands have been shown to be very good in removing metals, even some of those harder to treat metals like selenium and arsenic. And you can see in the photo in this particular slide an example of constructed wetlands for treatment on that large of a scale. You can sometimes remove them hydraulically, pumping them into geotubes. You leave these in place. There are lots of options. Constructability is always the issue. You plan ahead of time because ash will liquefy. Anybody who has had to dig this material knows that you dig it out of the pond and you put it in a truck, it looks like a solid. You haul it down the road and it turns to a liquid. So in order to deal with that, you've got to get the water out. To get the water out, it takes time. And again, back to the idea that don't plan on addressing this all at once. So the construction costs, next to last slide, you've got, you need to look at the ash volumes, the actual conditions versus design. These are things that can really mess up your budget. You assume that that pond was 20 feet deep because that's what the design drawings show. You get in there and it's 30 feet deep. Suddenly your volumes are 50% more. That can mess up your budget and that can make people mad. Moisture content. Don't pay to haul water. If you've got the time to start removing water, then do it now and you'll save yourself some money. Keep your haul distances short. Avoid double handling of materials. Again, this is all taken care of through appropriate planning. Sometimes synthetic construction materials can save you some money. Avoid long-term monitoring where possible. Look at on-site landfill construction versus off-site for the reasons that I mentioned. And then leachate management. What are you going to do with that leachate? And if you can do it with an on-site constructed wetland system, that may be the ticket for you. So that is the end of my presentation. I'll take any questions if you have any.
Thanks. Questions? Yes.
Julie Robinson with Southern Company. It's been a long time since I've been involved with landfill and this really what I do nowadays, ash management. So what are the industry what is industry looking at for concerns of your doing closure in place and having to do groundwater monitoring for establishing their background levels? What are those concerns?
Well, if I understand your question right, you want to know how do you establish a background level for your in-place closure for your groundwater. What is typically done on really any site is you want to get up gradient of whatever your impacting source may be. In this case, it would be your pond. So you would want to install wells up gradient of your pond. And typically that's acceptable to an agency. Because you obviously can't go back to time zero before the pond got there. So you want to find a location that is not potentially impacted by that pond.
My history was more with RCRA type work, and so that was always a difficult argument to make, even if it was up gradient. So I didn't know if the industry was seeing or had those concerns to establish those background levels.
Right. That's when we cite industrial landfills, that's typically our approach.
Any other questions?
Following on with one more question then, have you ever actually been able to end monitoring after 30 years? I never had any projects that we could.
I don't know if I've lived long enough since closure, but yes, yeah, I am familiar with a few that they've been in place long enough that they can end the monitoring, yes. But so it is a reality. We're just not there yet on most of these.
Great. Okay.
Okay,
Thank you,
you.
Kent.